All right, so we're moving on to part 2 of component 6, which is our double and half angle identities. So instead of drawing pictures of our triangles in these problems, these are all saying 75 degrees, negative pi over 8, etc. So these are using unit circle. So essentially we're saying sine of 75 is not on the unit circle. So let's use one of our formulas to use unit circle values so that we can figure out what sine of 75 is equal to. Okay, so we want to use double and half angle identities. So we know sine of 75. I could rewrite that as sine of 150 divided by 2, right? Because 150 divided by 2 is 75. So now that we know sine is 150 over 2, right, gives us 75. If we look, that means we're using our sine of x over 2. So that's telling us sine of x over 2 equals plus or minus 1 minus cosine of x over 2. So this is the same thing as plus or minus the square root of 1 minus cosine of x over 2. Now, in our part 1 problems, we replaced all of cosine of x, right? Because we knew cosine of x was equal to 3 over 4. But that's not what's happening here. This is saying sine of x over 2. So that's saying x is 150. So I'm going to replace x here with 150. Not all of the cosine, but just the x. So we've got 1 minus cosine of 150 all over 2. Now, just like before, this does not mean plus or minus. This means we're choosing, is it plus or is it minus? So let's look at this. So sine of 75 would be in quadrant 1. I get that 150 is not in quadrant 1, but sine of 75 is our answer. Sine of 75 would be in quadrant 1, and sine is positive in quadrant 1. So this answer is going to be positive. Now, we know that cosine of 150, that's a 30-degree angle, so it's going to be negative root 3 over 2 in quadrant 2. Cosine is negative. Now, subtracting a negative means add. I could make this 1 a 2 over 2. So that gives us 2 plus root 3 all over 2 all over 2. Now remember, all over 2 means we're dividing by 2, which means we're multiplying by a half. So that gives us 2 plus root 3 all over 4, because 2 times 2 gives us the 4. Now remember that we're taking the square root of this whole thing. Well, the square root of 4 is a perfect square, so we could say this is 2 plus root 3 all over regular 2, because the square root of 4 is 2. So this is our final answer. Okay, sine of negative pi over 8. So let's rewrite this as sine of negative, parenthesis negative, something over 2. Well, pi over 4 divided by 2 is going to give us pi over 8. So that's telling us negative pi over 4 is going to be the x. So we have sine plus or minus 1 minus cosine of x, which is negative pi over 4, all over 2. Now, sine of negative pi over 8, that's going to be in quadrant 4. And in quadrant 4, sine is negative, so I'm going to choose the negative here. So negative 1 minus cosine of pi over 4 is root 2 over 2. And this is in quadrant 4. Negative cosine is positive in quadrant 4. So we have minus positive root 2 over 2. I could make the 1 a 2 over 2, so that gives us 2 minus root 2 over 2 over 2. Same thing, 2 minus root 2 ends up being over 4 because of the over 2 turns into multiplying by a half, which just gives us 4. 4 is a perfect square, so we have 2 minus root 2 all over 2 because the square root of 4 is 2. Okay, number 9, you could rewrite 165 as the cosine of what divided by 2? Well, you could say that is 330 divided by 2. And then I want you to go through and see if you can finish this problem. So see if you can do this one and check your answers. I'm going to look at tangent of 15. So tangent of 15 I could rewrite as tangent of 30 degrees over 2, which is telling us x is 30. So if we look at our formula, tangent of x over 2 is 1 minus cosine of x over sine of x. And we know x is 30. So that gives us 1 minus cosine of 30 is root 3 over 2. Sine of 30 is 1/2. Make this a 2 over 2. 2 minus root 3 over 2 over 1/2. Our 2's here can cancel. Oops, sorry, you can't see that. So we have 2 minus root 3 all over 1, which is just 2 minus root 3. Okay, I want you guys to try 9 and 11 and then go check your answers.